Hello, in this video, I will explain to you on how to solve this problem. Number 25, Sunjamming. A sunyacht is a spacecraft with a large sail that is pushed by sunlight. Although such a push is tiny in everyday circumstances, it can be large enough to send the spacecraft outward from the sun on a cost-free but slow trip. Suppose that the spacecraft has a mass of 900 kilogram and receive a push of 20 Newton. Okay, so we will have the mass that will be 900 kilogram, and then the force that push it is 20 Newton. 20 Newton. So this is the net force that push it, right? And then I think we can just use the Newton's second law to answer the question A. What is the magnitude of the resulting acceleration? Okay, let's just do it. So I will have the net force is equal to the mass times acceleration. Good. Now the force is only 20 Newton, right? 20 Newton. And then the mass is 900 kilogram. And so we will have acceleration here. So we will have the acceleration here is 20 divided by 900. And 20 divided by 900, maybe let's just use calculator for that. 20 divided by 900. So I'll have 0.022. Okay, 0.022, and the unit here will be in meter over square seconds. Good. And this is our acceleration, which is the answer for the question A. However, we still need to answer question B and C. How far and then how fast it travels. And I think we have changed the question from Newton's second law to kinematics here. So we will have the initial velocity here, VO, is 0. Why? Because it is starting from the rest, right? It starts from rest here. So VO is equal to 0. And then the T is 1 day. The time is 1 day. But I think we need to convert it into SI unit. So 1 day, that will be, 1 day is 24 hours. Okay. And then 1 hour is 60 minutes. And then 1 minute is 60 seconds. So I will have this number here. So I will have 1 day in second is, we have 1 times 24 times 60 times 60. And that will be 86.86 seconds. Good. And now what can we get from here? I think we will have the VT, right? VT is equal to VO plus AT. I think we will answer question C first instead of B. Because this is easier, we can just plug that in. So we'll have VO is 0. And then the acceleration is 0.022 meter over square seconds. And then multiplied by 1 day. 1 day, I think, let's just write the number here. So I'll have 86.400. Okay, and then we will have, what is it? 0 plus 0.022 multiplied by 86,400. Good, and I will have 1900.8. Okay, 1900.8, and the unit here will be our meter over second. And this is question C. The answer for question C. This is our VT. However, we still have to answer question B. How far it will travel on 1 day. Okay, maybe let's clean this up here and get some space. Okay, so far we get these two values, and now we can just calculate one more values, which is how far it will travel. And I can use the kinematics formula. Vt squared is equal to VO squared plus 2AT. x, right? And we are looking for its displacement. So let's just plug that in. I will have 1900.8, and then VO is 0, so I have 0 here, so 0 squared, and then plus 2 multiplied by 0.022 multiplied by x, and this is also squared. Good, we can isolate x here, so we'll have x that will be 1900.8 squared divided by 2 and then multiplied by 0.022. And so we will have our x here. What is it? We will have 1900.8 squared and then divided by 2 multiplied by 0.022. Okay, and so I will have 82 million, okay, 82 million, and then 114, okay, 114, and then 560 meter, or maybe in kilometer we will have x is equal to 8200 114.56, and here the unit is kilometer. And I think this is the answer for question B, and I think we have answered all the question. This is the magnitude of the acceleration, and this is how far it travels after 1 day, and this is how fast it travels after 1 day. And I think that's all for this problem. Thank you for watching and see you in the next video. Bye bye.